universe is vast, filled with galaxies, stars, and planets. Yet everything we see, every atom, every particle of light, accounts for only about 5% of the total mass and energy in the cosmos. The remaining 95% consists of two mysterious entities, dark matter and dark energy. We cannot see them, we cannot directly detect them, yet their influence shapes the very fabric of reality. What are dark matter and dark energy? How do we know they exist if we cannot observe them directly? Are they merely gaps in our understanding of physics, or do they represent an entirely new kind of reality? In this deep dive, we will explore what science knows, what it doesn't, and the biggest mysteries that remain unsolved about these enigmatic forces. The discovery of dark matter, the invisible mass. In the 1930s, Swiss astronomer Fritz Zwicky observed something unusual in the Coma cluster, a collection of galaxies about 320 million light-years away. He calculated the gravitational pull needed to keep these galaxies together and realized that the visible matter, stars and gas, wasn't nearly enough. Something unseen had to be exerting extra gravity. He called this missing mass dunkle Materie, or dark matter. Decades later, in the 1970s, American astronomer Vera Rubin made another key discovery. She studied the rotation of spiral galaxies and found that their outer edges rotated just as fast as the inner regions. According to Newtonian physics, the outer stars should have been flung into space due to insufficient gravitational pull. The only explanation was that an invisible mass, dark matter, was holding them together. What could dark matter be? Since we cannot see or detect dark matter directly, scientists have proposed several possibilities. Weakly interacting massive particles, WIMPs. Hypothetical particles that interact only through gravity and the weak nuclear force, making them difficult to detect. Axions. Extremely light particles that may solve some fundamental problems in physics and could be detected through their interactions with magnetic fields. Primordial black holes. Small black holes formed in the early universe that could account for some of the missing mass. Modified gravity. Some scientists propose that what we call dark matter is actually a sign that our understanding of gravity is incomplete, requiring new physics beyond Einstein's relativity. Despite decades of searching, no direct evidence of dark matter has been found, leaving it one of the greatest cosmic mysteries. The mystery of dark energy, the universe's hidden force. If dark matter holds the universe together, dark energy is pushing it apart. In the late 1990s, two independent teams of astronomers studying distant supernovae made a shocking discovery. The universe's expansion is not slowing down as expected. It is accelerating. This was completely unexpected and required an explanation beyond current physics. The force responsible for this accelerated expansion was named dark energy, and it is believed to make up about 68% of the universe. But what exactly is it? Possible explanations for dark energy. The cosmological constant, lambda, proposed by Einstein as an energy inherent to space itself. This constant could drive the expansion of the universe. Quintessence, a dynamic, evolving form of energy that changes over time, unlike the static cosmological constant. Extra dimensions. Some theories suggest dark energy arises from interactions with hidden dimensions beyond our three-dimensional space, a flaw in general relativity. Perhaps our understanding of gravity is incomplete, and new physics is required to explain cosmic expansion. Despite its overwhelming influence on the universe, dark energy remains entirely theoretical, with no direct detection or understanding of its true nature, the cosmic tug-of-war. Dark matter versus dark energy. Dark matter and dark energy seem to be in constant opposition. Dark matter's gravity pulls galaxies together, forming large-scale cosmic structures. Dark energy, on the other hand, works in the opposite direction, stretching the fabric of space and pushing galaxies apart. If dark energy continues to dominate, the universe may face one of several possible fates: the Big Freeze, heat death. The universe expands forever, eventually cooling and becoming a vast, dark, and empty place. The Big Rip, dark energy grows so powerful that it eventually tears galaxies, stars, and even atoms apart. the big crunch. If dark energy reverses or weakens, the universe could collapse back in on itself, leading to a new Big Bang. The Big Bounce, a cycle of expansion and contraction, where the universe continually dies and is reborn. Which scenario will occur? We still don't know. Searching for answers. How scientists study the unseen. Despite their invisibility, scientists have devised clever ways to study dark matter and dark energy. Gravitational lensing. When dark matter bends light from distant galaxies, we can infer its presence. Cosmic microwave background, CMB. The oldest light in the universe carries subtle imprints of dark matter and dark energy's effects. Large Hadron Collider, LHC. Scientists hope to create or detect dark matter particles by smashing protons together at high speeds. Supernova surveys. Observing distant supernovae helps measure the rate of cosmic expansion and refine our understanding of dark energy. These experiments may eventually crack the code of these cosmic mysteries. Could we be wrong? Alternative explanations. As baffling as dark matter and dark energy are, some scientists believe they may not exist at all. Instead, they suggest MOND, modified Newtonian dynamics, a new theory of gravity that eliminates the need for dark matter. Emergent gravity. Gravity itself may emerge from quantum interactions, explaining galaxy rotations without invoking dark matter. Holographic universe theory. Some physicists propose that our universe is a projection of deeper underlying physics where dark matter and dark energy may not be needed. If one of these alternative theories proves correct, it would revolutionize our understanding of the cosmos, the biggest unsolved puzzle in the universe. Dark matter and dark energy make up 95% of everything, yet we have no idea what they really are. They shape galaxies, dictate the fate of the cosmos, and challenge the very foundations of physics. Are they undiscovered particles? Do they hint at hidden dimensions? Or are they signs that our understanding of the universe is fundamentally flawed? As our telescopes grow more powerful and experiments become more precise, we may one day unravel these cosmic mysteries. Until then, dark matter and dark energy remain the greatest unsolved riddles in the history of science. Time is one of the most fundamental aspects of our existence. We experience it as a constant, flowing from past to future, defining every moment of our lives. Yet physics tells us that time may not be what it seems. Could time be an illusion? Is it a physical entity or merely a human perception? Why does time seem to flow in one direction, and does it even exist at a fundamental level? In this deep dive, we will explore the mysteries of time, how different theories of physics approach it, whether time travel is possible, and what cutting-edge research tells us about its true nature. Could time be a construct of consciousness, an emergent property of the universe, or something even stranger? Let's unravel the enigma of time. The classical view of time, a linear river? For most of human history, time has been understood as a steady, linear progression. This perspective, deeply ingrained in our everyday experiences, suggests that the past is fixed, the present is fleeting, and the future is unwritten. This concept of time aligns with our daily experiences. We age, objects decay, and cause precedes effect. But is this perspective accurate, or is it just an illusion? Newton's absolute time. Sir Isaac Newton was one of the first to formalize a scientific understanding of time. He proposed that time was absolute, flowing uniformly and independent of the physical universe. In this view, time was like an invisible clock, ticking at a constant rate throughout the universe, unaffected by motion or gravity. For centuries, this classical understanding of time governed physics, aligning with our human intuition. However, as scientific discoveries advanced, this picture of time began to unravel. Einstein's revolution, the relativity of time. Albert Einstein's theories of special and general relativity shattered the Newtonian concept of absolute time. Instead of being an independent, universal constant, Einstein showed that time is relative and flexible. Time dilation, time slows down. One of the most startling discoveries of relativity is time dilation. The idea that time moves at different rates depending on speed and gravity. Velocity and time dilation. According to special relativity, the faster an object moves, the slower time passes for it relative to a stationary observer. If an astronaut were to travel close to the speed of light and return to Earth, they would have aged far less than people who remain behind, a concept demonstrated in experiments using high-speed particle accelerators and confirmed with atomic clocks. Gravity and time dilation. General relativity extended this idea by showing that gravity also affects time. The stronger the gravitational field, the slower time passes. This effect is so significant that clocks aboard GPS satellites, which experience weaker gravity than on Earth's surface, must be corrected to stay synchronized with ground-based clocks. These discoveries forced physicists to rethink time as a universal constant. Instead of flowing uniformly, time is malleable, bending and stretching depending on the observer's frame of reference. The arrow of time. Why does time flow in one direction? While Einstein showed that time is relative, another mystery remains. Why does time always seem to move forward? This is known as the arrow of time. The fact that we remember the past but not the future, that eggs break but never reassemble themselves, and that we age but never grow younger. The thermodynamic arrow of time. The most accepted explanation comes from the second law of thermodynamics, which states that entropy, disorder, always increases over time. In other words, the universe naturally evolves from states of low entropy, order, to high entropy, disorder. Ice melts into water but never spontaneously refreezes. A deck of shuffled cards doesn't naturally return to its original order. Stars burn out rather than reigniting themselves. This increase in entropy gives time its direction. However, this explanation raises an even deeper question. Why did the universe begin in such a low entropy state? The cosmological arrow of time. The universe started in a highly ordered low entropy state during the Big Bang. But why? Some physicists propose that our universe is just one part of a larger multiverse, where some regions have time flowing backward, others forward, and still others where time does not exist at all. If this is true, our perception of time as a one-way street may be a local feature rather than a fundamental truth. Quantum mechanics and the illusion of time. At the microscopic level, time behaves even more strangely. In the realm of quantum mechanics, particles do not move in a smooth, predictable manner, like objects in our macroscopic world. Quantum superposition and time reversibility. Quantum mechanics suggests that particles exist in multiple states at once, a concept known as superposition. Furthermore, many quantum processes are time reversible, meaning that they work equally well forward and backward in time. If the universe were purely quantum, we would expect no fixed arrow of time. Some physicists argue that time may not exist at the quantum level at all. The Wheeler-DeWitt equation. No time in quantum gravity. The Wheeler-DeWitt equation, an attempt to unify quantum mechanics with general relativity, does not contain a time variable. This has led some to propose that time may not be fundamental, but an emergent property arising from deeper laws of physics. If time does not exist at the quantum level, could our experience of time be nothing more than a construct of our consciousness? The psychological nature of time. Is time a human illusion? Some neuroscientists and philosophers suggest that time may not be an objective feature of reality, but rather a construction of the human mind. Time perception and the brain. Our brains perceive time differently based on various factors. Emotions. Fear or excitement can make time seem to slow down, while routine and boredom make it speed up. Age. Time appears to move faster as we age, likely because our brains process fewer new experiences as we grow older. Meditation and psychedelics. Certain mental states, including deep meditation and psychedelic experiences, can alter or even eliminate the perception of time altogether. If our sense of time is a product of the brain, could it mean that time itself is not fundamental? The possibility of time travel. Einstein's relativity allows for the theoretical possibility of time travel. But is it physically possible? Wormholes, hypothetical tunnels through space-time that could allow travel between different points in time. Cosmic strings, theoretical defects in space-time that could bend time around them. The twin paradox, A relativistic effect where one twin traveling near light speed ages slower than the other. Despite the theoretical possibilities, practical time travel faces significant challenges, such as paradoxes and the need for exotic matter. Conclusion: what is time really? Is time an absolute reality or just a human construct? Physics suggests that time is relative, malleable, and possibly non-existent at the quantum level. Meanwhile, our psychological experience of time raises even more questions about its true nature. Could time be a property of consciousness? Is it an emergent feature of the universe? Or is time simply an illusion, an artifact of how we process reality? As physics advances, we may one day unlock the true nature of time. Until then, it remains one of the deepest and most perplexing mysteries in science. Sleep is one of the most universal experiences across all forms of life, from humans to insects. Yet science still cannot fully explain why we do it. Every night, we surrender to an unconscious state for hours, unaware of our surroundings, vulnerable, and yet unable to resist the pull of sleep. Dreams, too, remain one of the most fascinating and mysterious aspects of the human experience. Why do we dream? What purpose do these strange and sometimes surreal narratives serve? Despite centuries of study, the exact reason we sleep and dream remains a profound mystery. In this deep dive, we will explore the science of sleep and dreams, what we know, what we don't, and the theories that attempt to explain these fundamental yet enigmatic aspects of life. Could sleep be an evolutionary adaptation, a method of memory processing, or something even more profound? Let's uncover the mystery of why we sleep and dream. The necessity of sleep. Why do we need it? One of the greatest mysteries in biology is why sleep is essential. Nearly every animal sleeps in some form, from mammals and birds to reptiles and even some insects. Yet sleep seems to be an inefficient and risky behavior. After all, sleeping animals are vulnerable to predators, unable to search for food, and incapable of responding to environmental dangers. If sleep wasn't crucial for survival, evolution likely would have eliminated it. So why do we need it? Effects of sleep deprivation studies have shown that prolonged sleep deprivation can have devastating effects on the body and brain. Cognitive decline, including memory loss and difficulty concentrating, increased stress, anxiety, and mood disorders, weakened immune function, making individuals more susceptible to illness, increased risk of obesity, heart disease, and diabetes. In extreme cases, prolonged lack of sleep can lead to hallucinations and even death. These effects highlight that sleep is not just a luxury, but a biological necessity. But what exactly happens when we sleep that makes it so important? The science of sleep, stages and functions. Scientists have categorized sleep into different stages, each playing a distinct role in our health and well-being. The stages of sleep occurs in cycles, typically lasting about 90 minutes each. These cycles consist of four main stages. Stage 1, NREM, light sleep, where the body begins to relax and brain waves slow down. Stage 2, NREM, a deeper stage of sleep, where body temperature drops and heart rate slows. Stage 3, NREM, slow wave sleep. The deepest stage of sleep, crucial for physical restoration, immune function, and memory consolidation. REM, rapid eye movement. Sleep, the stage where dreaming occurs, characterized by increased brain activity and temporary muscle paralysis. Functions of sleep. There are several theories about why sleep is essential. Restoration theory. Sleep allows the body to repair and regenerate cells, restore energy, and remove toxins from the brain. Memory consolidation. Sleep is crucial for processing information, strengthening neural connections, and enhancing learning. Energy conservation. Some scientists propose that sleep evolved to conserve energy when it was least needed, such as at night when food was harder to find. Brain detoxification. Recent studies suggest sleep helps clear metabolic waste from the brain through the lymphatic system, reducing the risk of neurodegenerative diseases. Each of these functions is crucial, yet none fully explain why sleep is so deeply ingrained in biology. Could there be an even greater purpose behind sleep? The mystery of dreams. Why do we dream? Dreaming is perhaps the most puzzling aspect of sleep. Every night our minds generate vivid, sometimes bizarre narratives filled with emotions, symbols, and events that often make little sense. But why? Theories of dreaming scientists and psychologists have proposed several theories about the purpose of dreams. Freud's psychoanalytic theory. Sigmund Freud suggested that dreams are a window into our unconscious mind, revealing repressed desires, fears, and conflicts. Activation synthesis theory. This theory suggests that dreams are the brain's way of making sense of random neural activity during REM sleep. Memory processing. Some researchers believe that dreams help consolidate memories and integrate new experiences with existing knowledge. Emotional regulation. Dreams may serve as a form of emotional processing, helping us cope with stress, trauma, and unresolved feelings. Threat simulation hypothesis. Evolutionary psychologists propose that dreams evolved as a way to rehearse survival scenarios, such as escaping predators or solving social conflicts. Despite these theories, there is no single agreed-upon explanation for why we dream. Some dreams feel deeply meaningful, while others seem purely nonsensical. Could there be a deeper function to dreaming that science has yet to uncover? The strange phenomena of dreams. Dreams often defy logic and reality, leading to intriguing questions about consciousness and the nature of the mind. Lucid dreaming. Lucid dreaming occurs when a person becomes aware that they are dreaming and can sometimes control their dreams. This phenomenon suggests that the dreaming mind is not entirely unconscious and raises questions about the brain's ability to create self-awareness even in altered states. Precognitive dreams. Some people claim to have dreams that predict the future, such as dreaming of an event before it happens in real life. While there is no scientific proof of precognitive dreams, the phenomenon has been reported across cultures and history. Recurring dreams and nightmares. Many people experience recurring dreams or nightmares, often involving the same scenarios or themes. Could these dreams be the brain's way of resolving deep-seated fears or unresolved emotions? The connection between sleep, dreams, and consciousness. Could sleep and dreams provide insights into the nature of consciousness itself? Some scientists suggest that dreaming is a form of consciousness exploration, allowing the brain to simulate different realities. Some philosophers argue that our waking state may be another form of dreaming, with reality being a complex simulation created by the brain. Studies on psychedelics show similar brain activity patterns to REM sleep, suggesting a connection between dreaming and altered states of consciousness. Some researchers believe that dreams might be a gateway to understanding higher dimensions of reality, expanding the possibilities of human perception. The unsolved mystery of sleep and dreams. Despite decades of research, the true purpose of sleep and dreams remains unknown. We know that sleep is essential for survival and that dreaming plays a role in mental and emotional processing. Yet the full picture is still elusive. Are dreams merely a byproduct of brain activity, or do they serve a deeper function? Is sleep just for restoration, or does it connect us to something greater? Until science uncovers definitive answers, sleep and dreams will remain one of humanity's greatest mysteries. The human body possesses an incredible ability to heal itself. But what if that healing could be triggered by belief alone? The placebo effect is one of the most perplexing and powerful phenomena in medicine. It occurs when a patient experiences real physiological improvements after receiving a treatment that has no active medicinal ingredients, simply because they believe it will work. For centuries, healers, doctors, and scientists have observed cases where patients recover due to the mere expectation of treatment. But how does this happen? How can a sugar pill, a saline injection, or even a simple ritual produce measurable changes in health? Despite extensive research, science has yet to fully explain the true power of the placebo effect. In this deep dive, we will explore what the placebo effect is, how it works, the theories behind it, and its implications for medicine, psychology, and the nature of healing. Could the mind truly have the power to influence the body's biology? Let's explore the enigma of the placebo effect. 1. What is the placebo effect? The placebo effect refers to the improvement in a patient's condition due to their belief in a treatment, rather than the treatment itself. Placebos can take many forms: sugar pills or fake medications that contain no active ingredients. Sham surgeries, where patients undergo a procedure that mimics a real surgery but without actual intervention. Fake injections, where patients receive saline solutions instead of real drugs. Symbolic treatments such as wearing copper bracelets for arthritis or using crystals for healing. In many cases, patients report reduced pain, improved symptoms, and even full recoveries simply because they expect the treatment to work. But how can belief alone trigger real physical changes? That is the central mystery of the placebo effect. 2. The science behind the placebo effect. Despite its mysterious nature, scientists have made significant progress in understanding how the placebo effect works. Research suggests that belief and expectation trigger actual biological responses in the body. Here are some key mechanisms. Neurotransmitter release studies have shown that the brain responds to placebos by releasing powerful chemicals. Endorphins, the body's natural painkillers, which function similarly to opioids. Dopamine, a neurotransmitter linked to pleasure, reward, and motivation. Serotonin, a chemical involved in mood regulation and well-being. These chemical changes can explain why placebos help alleviate pain, reduce anxiety, and even improve mood disorders. Conditioned responses. The placebo effect is often linked to classical conditioning, a psychological mechanism where the body learns to associate a stimulus with a response. For example, if a person repeatedly takes a real painkiller, their body associates the act of taking a pill with pain relief. When given a placebo pill, their brain anticipates pain relief and triggers a similar biological response. Expectation in perception. The human mind has a powerful influence over perception. If a person expects to feel better, their brain may alter their perception of pain or symptoms, making them experience genuine relief. Patients who believe they are taking a painkiller report lower pain levels. Individuals who think they are receiving an antidepressant experience mood improvements. People given placebo asthma inhalers breathe more easily, even though the inhaler contains no medicine. These studies suggest that belief alone can influence the brain's perception of discomfort, leading to real physiological benefits. 3. The placebo effect in medicine. Doctors and researchers have long observed the placebo effect in clinical settings. Even in randomized trials, placebo groups often show significant improvements. Here are some of the most striking examples. Pain relief without drugs. Many studies have shown that placebos can be as effective as real painkillers. For example, in a study on post-surgical patients, placebo morphine injections provided the same pain relief as real morphine when patients believed they were receiving the real drug. Patients with chronic pain who received fake acupuncture treatments reported the same level of relief as those who received real acupuncture. Depression and mental health placebos have been shown to improve symptoms in people with depression, anxiety, and other mood disorders. In antidepressant trials, around 50% of the improvement in patients can be attributed to the placebo effect. Even when people know they are taking a placebo, some still report improvements, showing the profound role of expectation in mental health. Sham surgeries that work. One of the most astonishing aspects of the placebo effect is sham surgeries, fake procedures where no real operation is performed, yet patients still improve. A study on knee arthritis surgery found that patients who received a sham procedure, where doctors only made an incision but did not repair anything, reported the same pain relief as those who had the real surgery. In spinal surgeries, patients who received placebo surgeries often showed similar improvements to those who underwent actual procedures. These cases demonstrate that the expectation of healing can sometimes be as powerful as the treatment itself. The limits and ethical dilemmas of placebos. Placebos don't work for everything. While placebos can be incredibly effective for pain management, mental health, and some physical symptoms, they do not cure diseases like cancer, infections, or broken bones. However, they can enhance symptom relief and improve quality of life for patients. The ethics of using placebos. The use of placebos in medicine presents ethical challenges. Is it ethical to deceive patients? If a doctor gives a placebo without informing the patient, is it a form of medical deception? Should placebos be prescribed openly? Some studies show that even when patients know they are taking a placebo, they still experience benefits. Could placebos replace some medications? If belief alone can trigger healing, could doctors use fewer drugs and more psychological interventions? These questions remain the subject of debate in medical ethics and practice. Could the placebo effect reveal the power of the mind? The placebo effect suggests that the human mind has extraordinary untapped potential to influence the body's healing processes. Could this phenomenon be connected to other unexplained aspects of consciousness? Mind-body healing. Ancient practices like meditation, hypnosis, and energy healing may tap into similar mechanisms as the placebo effect. The role of belief in health, religious faith healings, rituals, and spiritual practices often involve elements of the placebo effect. Future medical applications. Understanding how belief alters physiology could lead to groundbreaking new treatments that harness the placebo effect intentionally. The placebo effect, an unsolved mystery. The placebo effect remains one of the greatest mysteries in medicine. It reveals the deep connection between belief, perception, and physiology. Yet scientists still struggle to fully understand its mechanisms. If the mind can heal the body through belief alone, what else is it capable of? Could the placebo effect be harnessed to create more effective treatments? Could it unlock hidden aspects of human potential? Until we uncover the full truth, the placebo effect stands as a testament to the mind's mysterious power over the body. For centuries, scientists have tried to piece together the story of human evolution. Fossil records, genetic studies, and archaeological discoveries have provided incredible insights into our ancient past. However, there remain significant gaps in the timeline, often referred to as the missing link, where sudden leaps in human development raise questions about how we evolved into the intelligent, technologically advanced species we are today. Where do modern humans come from? Why do certain key evolutionary transitions seem to happen so rapidly? What explains the sudden emergence of intelligence, culture, and civilization? These are some of the questions that remain unanswered, despite decades of scientific research. In this deep dive, we'll explore the mysteries of human evolution, examining the key gaps in the fossil record, the unexplained bursts of development, and alternative theories about our evolutionary journey. Could our origins be more complex than traditional evolutionary theory suggests? Let's investigate. The fossil record, what we know. Fossils have been a crucial tool in understanding human evolution. They provide physical evidence of our ancestors and help reconstruct the evolutionary tree. The most well-known fossil discoveries include Australopithecus afarensis, Lucy, a 3.2 million-year-old hominin found in Ethiopia, showing bipedalism but with a small brain size. Homo habilis, handyman, an early species of human that used primitive tools, dating back 2.4 to 1.4 million years ago. Homo erectus, upright man, one of the longest surviving human species, showing significant brain growth and migration out of Africa. Neanderthals and Denisovans, close relatives of modern humans who lived alongside us and even interbred with early Homo sapiens. Despite these discoveries, there are large chronological gaps between these species, leaving questions about how one form transitioned into another. The fossil record does not always show clear, gradual changes, but instead suggests sudden evolutionary leaps. The mystery of sudden evolutionary leaps. One of the biggest challenges in explaining human evolution is the sudden appearance of advanced traits. Traditional evolutionary theory suggests that gradual changes over millions of years should shape species. Yet humans seem to have experienced rapid developments in several key areas: brain expansion and intelligence. The human brain increased threefold over a short evolutionary period, from 400 to 500 cubic centimeters in early hominins to over 1,300 cubic centimeters in modern humans. This massive leap in brain size is puzzling because other primates did not undergo such drastic brain expansion. Larger brains require significant energy, meaning a major shift in diet and metabolism would have been needed. Intelligence and language appear fully formed in early Homo sapiens without clear transitional fossils showing how they developed. Some scientists propose that genetic mutations or environmental pressures could explain these changes, But others argue that the timeline of human brain growth is still highly mysterious. The Great Leap Forward, 50,000 years ago. Roughly 50,000 years ago, humans experienced an abrupt explosion in cultural and technological advancements. Known as the Great Leap Forward, this period saw the emergence of complex language and symbolic thought, sophisticated tools, weapons, and art, social structures, trade networks, and early civilizations. Why did humans suddenly begin painting cave walls, burying their dead with rituals, and creating intricate tools when earlier hominins showed little evidence of such behaviors? Some scientists believe genetic changes played a role, while others suggest cultural and environmental factors contributed. The gaps in our evolutionary timeline. There are several points in human evolution where the fossil record is incomplete or where major transitions lack clear intermediates. These include the missing link between Australopithecus and Homo while Australopithecus afarensis, like Lucy, is considered a direct ancestor of Homo. There is a gap of nearly 1 million years between these early bipeds and the emergence of Homo habilis. What species existed in between? The sudden appearance of Homo sapiens. Modern humans, Homo sapiens, appeared around 300,000 years ago, but their full intellectual and cultural capabilities didn't emerge until much later. The transition from archaic humans to fully modern humans is still unclear. The disappearance of Neanderthals. Neanderthals thrived in Europe for hundreds of thousands of years, only to vanish mysteriously around 40,000 years ago. Were they outcompeted, assimilated, or wiped out by some unknown event? Alternative theories and explanations. Since gaps remain in our understanding of human evolution, several alternative theories have been proposed. Punctuated equilibrium. Some scientists suggest that evolution happens in bursts rather than gradually. This theory, known as punctuated equilibrium, proposes that species remain stable for long periods, then undergo rapid evolutionary changes due to sudden environmental shifts or genetic mutations. Hybridization with unknown hominins. DNA evidence shows that early Homo sapiens interbred with Neanderthals and Denisovans. Could other, yet undiscovered hominin species have contributed to our genetic makeup? Some researchers believe there may be ghost lineages, species that existed but left no known fossil traces. The role of external influences. Some controversial theories propose that external influences, such as extreme environmental changes, climate shifts may have forced rapid adaptations, unknown genetic mutations, certain DNA changes could have accelerated intelligence, extraterrestrial or unknown interventions. Some fringe theories suggest outside influences in our development, though these lack scientific evidence. While mainstream science does not support all these ideas, the gaps in the fossil record continue to fuel debate. The future of human evolution. As we continue to evolve, scientists wonder, what comes next? Will human intelligence continue to increase? Could technology and artificial intelligence influence future evolution? Will modern medicine and genetic engineering alter natural selection? These questions remain open-ended, as the future of human evolution may be as unpredictable as our past. The unfinished puzzle of human evolution. The story of human evolution is far from complete. While we have pieced together much of our past, significant gaps remain. The missing link in human evolution is not a single species, but rather a series of unexplained transitions and rapid advancements that challenge our understanding of how we became who we are today. As science progresses, new discoveries, whether through fossils, genetics, or archaeology, may eventually fill in these gaps. Until then, the missing link remains one of the greatest mysteries of our origins. On the night of August 15, 1977, a powerful radio signal from deep space was detected by Dr. Jerry R. Ehman at Ohio State University's Big Ear Radio Telescope. The signal lasted for 72 seconds, and its intensity was so remarkable that Ehman circled it on the printout and wrote a single word beside it. Wow! This moment gave birth to one of the greatest mysteries in the search for extraterrestrial intelligence, the WOW signal. Despite decades of investigation, the signal has never been replicated, traced, or explained. Was it a broadcast from an alien civilization, a natural cosmic event, or simply a mistake? In this deep dive, we'll explore what we know about the WOW signal, the theories surrounding it, and why it remains one of the most compelling pieces of evidence for the existence of extraterrestrial intelligence. The discovery of the WOW signal, the Big Ear radio telescope. In 1977, the Big Ear radio telescope was dedicated to searching for narrowband radio signals from deep space, signals that could indicate intelligent life. The telescope scanned the sky systematically, recording signals from various directions. On that fateful night, as the telescope observed the region near the constellation Sagittarius, an extraordinarily strong signal was recorded on the 1420 MHz frequency, a frequency associated with hydrogen, the most abundant element in the universe. What made the signal so unique? Several factors made the WOW signal stand out: strength and duration. It was 30 times stronger than background noise and lasted precisely 72 seconds, the time it took for the radio telescope to scan a given point in the sky. No earthly origin. The signal did not match any known human-made sources, satellites, or interferences. Narrow bandwidth. Natural cosmic sources like pulsars and quasars emit broad-spectrum signals. While this signal was highly focused and specific, a key characteristic of artificial transmission. Never repeated. Unlike pulsars or other cosmic phenomena, the WOW signal has never been detected again, despite numerous follow-up attempts. This combination of factors led to the speculation that the signal could have been an intentional transmission from an advanced civilization. Possible explanations for the WOW signal. Since its discovery, scientists have proposed various explanations, both natural and artificial, to solve the mystery of the WOW signal. Extraterrestrial intelligence, SETI hypothesis. One of the most exciting possibilities is that the WOW signal was a radio transmission from an alien civilization. Here's why this idea remains compelling. The 1420 MHz frequency. This frequency is associated with hydrogen, which is a logical choice for extraterrestrial communication, since hydrogen is the most abundant element in the universe. Non-natural characteristics. The WOW signal had properties not typical of known astrophysical sources. Intentional transmission theory. Some speculate that an advanced civilization might be intentionally broadcasting signals toward habitable star systems. However, without a second detection, it remains impossible to verify this theory. Natural cosmic phenomena. Some scientists believe the WOW signal could have been a natural space event that we misinterpreted as artificial. Proposed sources include comet reflections. A recent theory suggests that comets 266P/Christensen and P/2008Y may have emitted hydrogen signals as they passed through the observed area. However, this theory remains debated. Interstellar scintillation, a distant pulsar or quasar signal, could have been temporarily magnified by gravitational lensing or interstellar plasma effects. Unknown astrophysical sources. There may be natural cosmic radio sources we have yet to identify. Terrestrial interference. Another possibility is that the WOW signal was caused by human-made radio interference, such as a secret military transmission. Some speculate it could have been a classified military signal, a passing satellite or aircraft. While no known satellites match the location, unknown sources remain a possibility. Equipment malfunction. A glitch in the radio telescope's electronics could have produced a false positive. Despite these theories, no known human-made source has ever been found to match the characteristics of the WOW signal. The search for a repeat signal. Following the discovery of the WOW signal, scientists made multiple attempts to redetect it or find a similar signal, but none have been successful. Efforts include SETI's follow-up observations. The search for extraterrestrial intelligence, SETI, directed multiple telescopes at the same region of space in the years following, but no repeat signal was found. The 2016 Comet Hypothesis Test. Researchers tested the idea that comets cause the WOW signal, but results were inconclusive. Modern radio astronomy. Survey's new highly sensitive telescopes continue scanning space for signals, but none have matched the WOW signal's properties. The fact that the signal has never been repeated remains one of the biggest challenges in confirming its origin. Could the WOW signal be a message from an alien civilization? Many scientists remain open to the possibility that the WOW signal was a deliberate transmission from an advanced extraterrestrial intelligence. Some possible scenarios include a beacon signal. A civilization might send signals at long intervals, and we just happen to catch one. A directed message. Perhaps the signal was meant for another civilization, and we only intercepted it by chance. A lost signal. Maybe the source has since shut down, moved, or changed frequencies. If an intelligent species sent the WOW signal, they may still be out there, waiting for us to reply. The future of the search for extraterrestrial intelligence. The WOW signal remains the strongest candidate for an alien transmission ever detected, but science continues to advance. Ongoing and future efforts include Breakthrough Listen Initiative, a $100 million project scanning the universe for potential alien signals. The Square Kilometer Array, SKA, a powerful new radio telescope that will significantly increase our ability to detect faint cosmic signals. AI and machine learning. New technologies are being used to analyze massive amounts of radio data more efficiently. The hope is that one day we may detect another WOW signal, or even better, a pattern that confirms intelligent life beyond Earth. A cosmic mystery that endures the WOW signal remains one of the most tantalizing mysteries in the search for extraterrestrial intelligence. Was it a message from another civilization, a natural cosmic event, or just an anomaly? Until we detect another similar signal, the mystery will remain unsolved. But as technology improves and as our search expands, the chances of finding a definitive answer grow ever stronger. Lightning is one of nature's most well-documented and understood phenomena. Yet there is one form of it that continues to baffle scientists and defy physics: ball lightning. Unlike regular lightning bolts that last only milliseconds, ball lightning appears as glowing orbs that can hover, move erratically, and even pass through solid objects like walls. Reports of ball lightning span centuries and cultures, yet science still struggles to explain exactly what causes these mysterious glowing spheres. Is ball lightning a rare weather phenomenon, an illusion, or something even stranger? In this deep dive, we will explore what ball lightning is, documented sightings, scientific theories, and the biggest questions that remain unanswered. Could understanding ball lightning lead to breakthroughs in physics? Let's find out. What is ball lightning? Ball lightning is a rare and unexplained luminous sphere that typically appears during thunderstorms. Unlike ordinary lightning, which is a quick discharge of electricity, ball lightning appears as a glowing orb ranging in size from a few centimeters to several meters in diameter. Moves unpredictably, sometimes hovering, bouncing, or following paths through the air. Can last for several seconds to over a minute, far longer than traditional lightning strikes. Has been reported to pass through walls, windows, and closed doors, an effect that seemingly defies known physics. Often disappears silently, but can also explode violently, sometimes leaving behind burns or damage. While ball lightning has been observed for centuries, there is still no widely accepted scientific explanation for its existence. Historical and modern sightings reports of ball lightning go back hundreds of years, with numerous well-documented cases throughout history. Historical accounts: 18th century, Georg Richmann's death, 1753. The German physicist Georg Wilhelm Richmann was reportedly struck by ball lightning while conducting an experiment with atmospheric electricity, leading to his instant death. The Great Thunderstorm of Widecombe, 1638. During a church service in England, a great ball of fire reportedly entered the church, killing several people and burning parts of the structure. Modern cases, 1960s. Russian sightings. Soviet scientists reported multiple cases of ball lightning appearing inside airplanes and laboratories, leading to government-funded research into the phenomenon. 1994 Chinese jet incident. A glowing orb of ball lightning allegedly entered a passenger jet's cabin, floated through the interior, and exited without causing damage. 2012 recorded observation. For the first time, Chinese scientists accidentally recorded ball lightning during a thunderstorm, providing rare scientific data on its spectral composition. Despite advancements in technology, most sightings remain anecdotal, and conclusive evidence remains elusive. Scientific theories on ball lightning. Since ball lightning is difficult to study in controlled environments, scientists have proposed several theories to explain its mysterious properties. Some of the most well-supported ideas include plasma theory. One of the most popular explanations suggests that ball lightning is a type of plasma, similar to the ionized gas found in neon lights or the sun's corona. However, scientists still struggle to explain how this plasma could form and sustain itself for extended periods. Vaporized silicon hypothesis. Some researchers propose that ball lightning forms when lightning strikes soil rich in silicon, vaporizing it into glowing airborne particles. This could explain its floating behavior and occasional explosions upon dissipation. Microwave cavity theory. A more exotic theory suggests that ball lightning is caused by microwave radiation trapped in a self-contained electromagnetic cavity, similar to how a microwave oven heats food. This could explain why some reports describe ball lightning passing through solid objects. Quantum and extra-dimensional explanations. Some fringe theories even suggest that ball lightning might involve exotic physics, such as quantum fluctuations or interactions with extra dimensions. While speculative, these ideas highlight how little we truly understand about the phenomenon. The most unexplained characteristics of ball lightning. While theories abound, several aspects of ball lightning remain especially perplexing. Its ability to pass through solid objects. Many reports describe ball lightning entering buildings through windows, walls, or even closed doors without leaving physical damage. If true, this suggests an unknown mechanism that allows electrical discharges to interact with solid matter in unprecedented ways. Its unexpected longevity, unlike typical lightning, which lasts only fractions of a second, ball lightning can persist for up to a minute or longer. No known electrical discharge should be able to sustain itself for that long. Its erratic movement. Ball lightning does not follow simple paths dictated by gravity or wind. Instead, it appears to move with intelligence, sometimes stopping, reversing direction, or following people. Its unpredictable disappearance. Ball lightning sometimes fades away silently, while in other cases, it explodes with a loud bang, leaving behind scorched surfaces. The reason for these different endings remains unknown. The search for answers. Can we create ball lightning? Scientists have attempted to reproduce ball lightning in laboratory conditions, with some success. Electromagnetic chamber experiments. Researchers have generated glowing plasma spheres using high-voltage discharges in controlled environments. Silicon combustion tests. Some experiments have produced glowing balls by vaporizing silicon, mimicking proposed natural formation mechanisms. Microwave-induced plasma. Certain microwave-based experiments have yielded plasma orbs that behave similarly to ball lightning. Despite these successes, no experiment has fully recreated all the observed properties of real-world ball lightning, leaving the mystery unsolved. Could ball lightning reveal new laws of physics? Some researchers believe that unlocking the secrets of ball lightning could lead to breakthroughs in plasma physics, energy storage, and even antimatter research. If ball lightning is a manifestation of unknown physical processes, studying it could open doors to entirely new scientific fields. Could ball lightning help us understand controlled fusion, the key to unlimited clean energy? Could it be a naturally occurring form of exotic matter? Does ball lightning hold clues to electromagnetic propulsion or other advanced technologies? Until we have definitive answers, ball lightning remains one of the most tantalizing unsolved puzzles in atmospheric science. A mystery that refuses to fade. Ball lightning is one of the strangest and most elusive natural phenomena ever recorded. While theories abound, its unpredictable nature, ability to pass through solid objects, and unexplained longevity continue to challenge our understanding of physics. Was ball lightning a misunderstood atmospheric phenomenon, an exotic form of plasma, or something yet to be discovered? Future research and advancements in physics may one day unlock its secrets, but for now it remains an electrifying mystery that defies explanation. One of the most perplexing and controversial mysteries in modern physics is the tetra-neutron mystery. The possibility that 4 neutrons alone can form a stable or semi-stable structure. According to theoretical nuclear physics, this should be impossible. Neutrons, which lack an electric charge, typically need protons to form a stable atomic nucleus, as the strong nuclear force alone is not sufficient to bind neutrons together in groups beyond 2. Yet experimental evidence suggests that a 4-neutron system, tetraneutron, may exist, challenging the fundamental principles of nuclear physics and quantum mechanics. Could this be a new form of exotic matter? Does it reveal an unknown force in physics? In this deep dive, we explore what scientists know about the tetraneutron, the experiments that suggest its existence, and what it could mean for our understanding of the universe. What is the tetraneutron? In simple terms, a tetraneutron is a hypothesized cluster of 4 neutrons bound together without protons. In conventional nuclear physics, neutrons alone should not be able to form stable structures beyond a dineutron, 2-neutron system, which itself is only fleetingly bound. The reason for this is that the strong nuclear force, the force that binds protons and neutrons together in an atomic nucleus, requires the presence of protons. Without an electric charge to create an additional stabilizing force, neutrons alone should not be able to remain bound for more than a fraction of a second. However, recent experiments challenge this assumption. Experimental evidence for the tetraneutron. While theoretical physics predicts that a tetraneutron cluster should be highly unstable, several experiments suggest otherwise. Early attempts and controversial results. The first serious claim of tetraneutron evidence came in 2002, when a team led by Francesco Miguel Marques at the GANIL, Grand Accélérateur National Lyon-Lourdes, laboratory in France reported detecting signals that suggested the formation of tetraneutron clusters. Their experiment involved bombarding beryllium-14 nuclei with high-energy neutrons, and the results suggested that 4 neutron clusters were produced as part of the reaction. However, the findings were highly debated, as they lacked direct confirmation and reproducibility. Critics argued that the observed signals could be statistical noise or misinterpretations of the data. The breakthrough 2016 Riken experiment. A major development occurred in 2016 when researchers at Riken, Japan, conducted a new experiment. This time, they bombarded helium-8 nuclei with protons and measured the resulting neutron interactions. Their data suggested a brief formation of a tetra-neutron resonance, a system that, while not completely stable, lasted long enough to suggest some level of binding. This was the first semi-confirmed experimental hint that 4 neutrons could temporarily stick together. Yet physicists remained cautious, calling for further experiments before confirming the tetraneutron's existence. 2022. Breakthrough with stronger evidence. In 2022, another breakthrough came from a team at Riken, led by Toshiyuki Kondo. They conducted a new and more refined experiment where they observed a tetra-neutron resonance state lasting for an estimated 10 to the power of -22 seconds. While fleeting, this was longer than previously expected, suggesting that some kind of force beyond current nuclear physics might be at play. Why shouldn't the tetraneutron exist? From a theoretical standpoint, the tetraneutron contradicts fundamental nuclear physics in several ways. Lack of a charge stabilizing force. Unlike protons, neutrons do not experience electrostatic repulsion, but they also lack the attractive force needed to keep them bound together in clusters. Strong nuclear force limitations. The strong force binds protons and neutrons within a nucleus, but it should not be strong enough to hold 4 neutrons together in a stable form. No known energy levels for a tetraneutron state. Current nuclear models do not predict an energy level where 4 neutrons could exist in a bound state. These contradictions suggest that if tetraneutrons do exist, there might be an unknown force or nuclear interaction that has yet to be discovered. What could this mean for physics? If the Tetra neutron truly exists, it could reshape fundamental nuclear physics and lead to groundbreaking new discoveries. Some potential implications include a new type of nuclear interaction. The existence of a Tetra neutron would imply that there may be an unknown aspect of the strong nuclear force that allows for temporary neutron binding. This could lead to revisions in quantum chromodynamics, QCD, the theory that describes nuclear interactions. Exotic states of matter. Could Tetra neutrons be the first step toward discovering an entirely new state of matter? Some physicists speculate that large collections of bound neutrons, neutronium, could exist in extreme environments, such as inside neutron stars. Neutron star physics understanding Tetra neutrons could provide insights into the behavior of neutron stars, the incredibly dense remnants of supernovae. If neutrons can form bound clusters, this could impact models of neutron star structure and evolution. Implications for the search for dark matter. Some speculative theories suggest that exotic nuclear states might contribute to dark matter, the invisible mass that makes up most of the universe. Could Tetra neutrons be linked to unknown dark matter interactions? What's next? Future research and challenges. Despite the exciting experimental hints, definitive proof of Tetra neutrons remains elusive. Scientists are now planning more advanced experiments to confirm their existence. 1. Higher precision experiments. Physicists are working on experiments using particle accelerators with improved detectors to capture fleeting neutron interactions, more refined quantum simulations to predict possible binding mechanisms. Theoretical advancements. If Tetra neutrons exist, nuclear physics models will need to be revised. This means exploring beyond the standard model of physics, testing new nuclear binding theories that might account for neutron-only structures. International collaborations with major institutions like CERN, Riken, and Ganil involved in the search, we may soon reach a breakthrough in understanding this strange phenomenon. Conclusion: the unsolved puzzle of the Tetra neutron. The Tetra neutron remains one of the most mysterious unsolved questions in nuclear physics. If confirmed, it would challenge existing theories, potentially revealing new forces, exotic matter, or even new physics beyond the standard model. Could the Tetra neutron lead to revolutionary discoveries in energy, astrophysics, or even quantum mechanics? Only time will tell. The question of why the universe exists at all is perhaps the deepest and most perplexing mystery in physics and philosophy. According to our current understanding of physics, when the universe was born in the Big Bang, equal amounts of matter and antimatter should have been created. But matter and antimatter annihilate each other upon contact, converting into pure energy. If the universe followed these rules perfectly, it should have resulted in a lifeless void. Yet here we are, in a universe filled with galaxies, stars, and life itself. Why does something exist instead of nothing? What caused the slight imbalance that allowed matter to dominate over antimatter? Are there hidden laws of physics that explain why our reality took shape? In this deep dive, we will explore the mystery of existence, the theories proposed by scientists, and the questions that remain unanswered. The matter-antimatter problem, the Big Bang and the expected symmetry. The Big Bang, the birth of the universe, occurred about 13.8 billion years ago, giving rise to unimaginable amounts of energy. This energy condensed into particles that would eventually form atoms, planets, and galaxies. However, for every particle of matter, like protons and electrons, an equal particle of antimatter, antiprotons and positrons, should have been produced. In theory, matter and antimatter should have completely annihilated each other, leaving behind a universe filled only with energy, light and radiation. Instead, a tiny excess of matter survived, forming the universe we see today. The question is, why? Theoretical explanations for the matter-dominated universe. Scientists have proposed several theories to explain why matter dominates over antimatter. Some of the most compelling ideas include CP violation, a fundamental asymmetry in physics. One possible explanation lies in a phenomenon called CP violation, charge parity violation. In simple terms, CP violation means that the laws of physics treat matter and antimatter slightly differently. In 1964, Experiments with kaons, a type of subatomic particle, showed that their decay favored matter over antimatter by a tiny fraction. More recent studies on B mesons have also revealed a slight preference for matter over antimatter. These asymmetries, though extremely small, may have accumulated in the early universe, leading to an excess of matter. However, the CP violations observed so far are not strong enough to explain the vast imbalance of matter and antimatter in the universe. This suggests that additional unknown physics may be at play. Baryogenesis, the process that created more matter. Baryogenesis is a theoretical mechanism that proposes a way for excess matter to form in the early universe. For baryogenesis to work, three key conditions must be met. Baryon number violation. There must be a process that allows protons and neutrons to be created in greater numbers than their antimatter counterparts. CP violation. As mentioned earlier, matter and antimatter must behave differently. Departure from thermal equilibrium. The early universe must have had conditions that temporarily disrupted perfect symmetry. While several models of baryogenesis have been proposed, no single theory has been confirmed by experiments. The role of neutrinos. Could they hold the answer? Neutrinos, tiny ghost-like particles that barely interact with matter, may hold a clue to the mystery of existence. Some theories propose that neutrinos have a special property called leptogenesis, which could have triggered a chain reaction leading to a matter-dominated universe. If neutrinos have a Majorana nature, meaning they are their own antiparticles, it could provide a missing ingredient for explaining matter-antimatter asymmetry. Experiments like those at CERN and Japan's T2K neutrino experiment are actively investigating whether neutrinos exhibit matter-favoring properties. Alternative theories. Could the answer lie beyond the standard model? While current physics provides some clues, the full answer may require new laws of nature. Some alternative theories propose the multiverse hypothesis. If our universe is just one of many in a multiverse, then some universes could have different physical laws where matter and antimatter are balanced differently. Our universe may simply be one where the right conditions for excess matter randomly occurred. Time-reversed universes. Some physicists propose that antimatter may dominate in a mirror universe, where time flows in the opposite direction. This means our universe could have a hidden twin, where antimatter survived instead of matter. Exotic physics, hidden particles, or forces. Some unknown force could have acted on the early universe, tipping the balance in favor of matter. New particles predicted by supersymmetry, SUSY, could explain why matter dominated. Dark matter may play a role in this mystery, but its connection remains speculative. Could we ever prove why the universe exists? Physicists are conducting groundbreaking experiments to search for clues. The Large Hadron Collider, LHC, smashing particles together to uncover hidden asymmetries. Neutrino observatories, investigating whether neutrinos break matter-antimatter symmetry. Deep space observations, looking for regions of the universe where antimatter might still exist. Each new discovery brings us closer to understanding why the universe didn't just vanish in a flash of energy billions of years ago. The philosophical question, why something instead of nothing? Even if physics finds an answer, a deeper philosophical question remains. Why does anything exist at all? Is existence simply a mathematical necessity? Did the universe emerge from nothing due to quantum fluctuations? Could existence be an illusion, a simulation, or a projection of deeper reality? These questions push the boundaries of both science and philosophy, reminding us that some mysteries may never be fully answered. The greatest mystery of all. The fact that the universe exists at all is a profound mystery that challenges our understanding of physics, cosmology, and philosophy. If matter and antimatter should have annihilated each other, yet an imbalance allowed the cosmos to form, what caused it? Solving this mystery could lead to groundbreaking discoveries about the origins of the universe, the nature of reality, and even the fundamental laws of physics. Until then, we continue to explore, experiment, and question the very nature of existence itself. Every year, millions of animals embark on incredible migratory journeys across vast distances, some spanning thousands of miles across oceans, continents, and even entire hemispheres. Birds, butterflies, fish, and even some mammals navigate these immense routes with astonishing precision, often returning to the exact locations where they were born, despite never having been there before. How do they do it? How can birds fly across the globe without getting lost? How do monarch butterflies complete a multi-generational migration and still reach the same forests as their ancestors? Even more puzzling, how do salmon find their way back to the exact river in which they were born after years in the open ocean? Despite decades of research, scientists still don't fully understand how animals accomplish these feats. In this deep dive, we'll explore the incredible mystery of animal migration and navigation, the theories scientists have proposed, and the questions that remain unanswered. The astonishing journeys of migratory animals. Many animals undertake incredibly precise and often perilous journeys. Here are some of the most remarkable examples. Birds, masters of the sky Arctic terns. These birds hold the record for the longest migration of any known animal, traveling up to 50,000 miles each year between the Arctic and Antarctica. Bar-tailed godwits. These birds complete the longest nonstop migration, flying 7,000 miles over the Pacific Ocean without resting. Swallows and starlings. These birds migrate thousands of miles annually, navigating by some unknown internal compass. Monarch butterflies, the multi-generational travelers. Monarch butterflies migrate from Canada to Mexico, but no single butterfly completes the journey. Instead, it takes 4 generations to finish the full migration cycle, with each generation instinctively continuing the route of their ancestors. Fish, navigating the oceans with precision. Salmon. After spending years in the ocean, salmon return to the exact rivers where they were born, overcoming rapids, predators, and enormous distances. Eels, European and American eels, migrate thousands of miles to the Sargasso Sea to spawn, and their offspring somehow find their way back to the exact river systems their parents came from. Mammals and other species. Wildebeest. Every year, over 1.5 million wildebeest migrate across the Serengeti in search of fresh grasslands. Green sea turtles. These turtles travel thousands of miles through the ocean and return to the same beaches where they were born to lay eggs. These examples highlight nature's incredible precision. But how exactly do these animals navigate with such accuracy? Theories of animal navigation. Scientists have proposed several mechanisms that might explain how animals navigate so precisely. While some have been partially confirmed, many remain mysteries. The sun and star compass. Many birds, insects, and marine animals appear to use the sun and stars as a natural compass. Birds like swallows and pigeons can navigate by the position of the sun. Night migrating birds adjust their flight paths based on star patterns. Some fish, like salmon, may use celestial cues to determine direction. While this method is effective, it does not explain how animals navigate on cloudy days or through dense forests and oceans where these celestial cues are blocked. The Earth's magnetic field, an internal GPS? One of the most compelling theories suggests that animals can detect the Earth's magnetic field using an internal biological compass. Many migratory birds have tiny magnetite crystals in their beaks, which may allow them to sense magnetic fields. Monarch butterflies have been found to use antennae proteins sensitive to magnetic fields. Loggerhead sea turtles appear to imprint the magnetic field of their birthplace and use it to navigate back years later. While the magnetic sense hypothesis is widely accepted, scientists still don't know exactly how animals process this information and convert it into precise routes. Olfactory maps. Navigating by smell, some animals, particularly fish and birds, may use scent-based navigation. Salmon use chemical signatures in rivers to identify their birthplace. Pigeons have been shown to use odor maps to navigate home. While compelling, this doesn't fully explain how animals navigate over thousands of miles in open oceans or skies with no scent trails. Quantum mechanics in animal brains? One of the most intriguing and speculative theories suggests that some animals may navigate using quantum entanglement. Recent research suggests birds may have a quantum-based compass in their eyes, allowing them to detect Earth's magnetic field at a subatomic level. The cryptochrome protein found in bird retinas appears to be influenced by quantum mechanics, helping them see magnetic fields. If true, this would be one of the most groundbreaking discoveries in biology, revealing a completely unknown sensory system. The remaining mysteries of animal navigation. Despite advances in research, several major questions remain unanswered. How do animals make course corrections? Even when displaced or faced with storms, they find their way back. How is navigational knowledge passed across generations? Monarch butterflies and eels migrate without ever having made the journey before. Are there unknown sensory mechanisms at play? Could animals be using cues we haven't yet discovered? These unanswered questions make migration and navigation one of nature's greatest enigmas. 4. Why studying migration matters. Understanding how animals navigate could have profound implications for both science and technology. Improved GPS and navigation systems. If we unlock nature's GPS, we could develop better autonomous vehicles and robotic navigation systems. Conservation efforts. Many migratory species are threatened by climate change and habitat destruction. Understanding migration could help us protect them. Understanding human evolution. Some scientists believe early humans may have had a similar magnetic sense that helped them explore the globe. By studying how animals navigate, we may discover new laws of nature that could transform the way we understand the world. Conclusion. The greatest journey of all, animal migration and navigation, remain one of the greatest mysteries of science. Despite incredible discoveries, we still do not fully understand how animals navigate the vast world with such precision. Are animals tapping into a hidden sensory system beyond our understanding? Could they be using a form of quantum biology? Or is their ability a result of millions of years of evolution, honing instincts beyond what we can measure? As technology advances, we may one day unlock the full secrets behind animal navigation. Until then, the migration of birds, butterflies, and fish continues to be one of nature's most astonishing and unsolved mysteries. Deep in the cosmos, hidden beyond the Milky Way, lurks a gravitational anomaly so massive that it is pulling entire galaxies toward it. This mysterious force, known as the Great Attractor, is located approximately 150 to 250 million light-years away in the direction of the Norma and Centaurus clusters. Despite its immense influence, we cannot directly see it. Its nature and composition remain unknown. What is the Great Attractor? Is it a supermassive black hole, a hidden galactic cluster, or an unknown force of physics? Why is it pulling galaxies toward it? And what secrets does it hold about the structure of the universe? In this deep dive, we will explore what scientists know, what they don't, and why the Great Attractor remains one of the most perplexing mysteries in modern astrophysics. The discovery of the Great Attractor. The existence of the Great Attractor was first inferred in the 1970s and 1980s, when astronomers noticed something strange. Galaxies in our local region of the universe are moving toward a specific point in space at speeds of over 600 kilometers per second. The Milky Way, Andromeda, and thousands of other galaxies are not simply drifting due to cosmic expansion. They are being pulled toward an unknown mass. This motion contradicts predictions based solely on the known distribution of matter in the universe. By analyzing the movement of galaxies using redshift measurements, which indicate motion away from us, and blueshift measurements, motion toward us, astronomers determined that something enormous was exerting a gravitational pull on a massive scale. But there was a problem. This mysterious force is hidden behind the zone of avoidance, a dense region of the Milky Way filled with gas, dust, and stars that obscures our view. The scale of the Great Attractor's influence. How powerful is it? The Great Attractor's gravitational pull is influencing a vast portion of the observable universe. It affects the motion of the Milky Way and the entire local group, which includes Andromeda and over 54 other galaxies. The Laniakea supercluster, a vast structure of over 100,000 galaxies, is being drawn toward this mysterious force. Despite its pull, dark energy continues to drive the overall expansion of the universe, making the dynamics even more complex. The Virgo supercluster, which contains our galaxy, is moving toward the Great Attractor's gravitational well. But the true source of this attraction remains hidden and unexplained. Theories about the nature of the Great Attractor. Since we cannot observe the Great Attractor directly, scientists have proposed several possible explanations for what it might be. A supermassive galaxy cluster. One possibility is that the Great Attractor is a region of space densely packed with galaxies, dark matter, and cosmic structures. The Norma cluster, a massive cluster of galaxies, is located near the suspected location of the Great Attractor. The Hydra Centaurus supercluster, one of the largest known structures, also lies in this region. If these structures are even larger than we estimate, they could be the main source of the gravitational pull we detect. However, the total mass of the observed galaxy clusters does not fully account for the observed pull, suggesting there is something more. A massive dark matter concentration. Dark matter, the invisible substance that makes up about 85% of the universe's matter, may play a major role in the Great Attractor's pull. If a gigantic dark matter halo exists in this region, its gravity could be pulling galaxies toward it. The lack of visible mass makes this explanation plausible, as dark matter cannot be detected directly. Only its gravitational effects are measurable. The problem? We still don't fully understand dark matter, making this theory highly speculative. A cosmic void, creating an illusion? Some astrophysicists propose that instead of being pulled toward an object, galaxies may be moving away from a massive void. If a huge low-density region of space exists near the Great Attractor, then galaxies on the edge of this void could be moving toward denser regions, creating the illusion of attraction. Cosmic voids are known to exist, and they influence galaxy movement. Could this be the explanation? The Shapley supercluster, a bigger cosmic force. Recent studies suggest that the Shapley supercluster, a structure 10 times more massive than the Great Attractor, may be playing an even greater role in the cosmic flow of galaxies. Located 650 million light-years away, the Shapley supercluster may exert an even stronger gravitational influence. If true, the Great Attractor may not be the ultimate force. It could just be a stepping stone in an even larger cosmic movement. The biggest unanswered questions. Despite decades of study, many questions about the Great Attractor remain unsolved. What exactly is it? Is it a massive cluster, a dark matter structure, or something we haven't yet imagined? Why can't we see it? Is it truly hidden, or is our understanding of cosmic motion incomplete? What role does dark energy play? If the universe is expanding due to dark energy, how does that affect the gravitational pull of the Great Attractor? What lies beyond it? If the Shapley supercluster is even more powerful, what other forces are shaping the universe? These questions continue to drive new research and discoveries in cosmology. The future of research on the Great Attractor. With advances in technology, we are closer than ever to unlocking the secrets of the Great Attractor. Here's how scientists are investigating it. Infrared and radio telescopes. Instruments like the James Webb Space Telescope, JWST, and the Square Kilometer Array, SKA, are allowing us to see beyond the dust and gas of the Milky Way. Gravitational wave observations. New methods in gravitational wave detection could reveal hidden cosmic structures. Dark matter studies. If dark matter is responsible for the pull of the Great Attractor, future experiments like those at the Large Hadron Collider, LHC, may provide clues. As our tools improve, we may finally uncover the true nature of the Great Attractor. A mystery that pulls us in the Great Attractor remains one of the most intriguing and unsolved mysteries in astrophysics. It is a gravitational enigma, pulling entire galaxies toward it while remaining hidden behind the cosmic veil. Could it be a colossal galaxy cluster, a massive dark matter structure, or something even stranger? Understanding the Great Attractor will not only reveal more about the structure of our universe, but could also challenge and refine our fundamental theories of gravity, dark matter, and cosmic evolution. Until then, this mysterious force continues to pull us, both scientifically and metaphorically, toward the unknown. In 1901, divers off the coast of the Greek island of Antikethyra discovered a mysterious, corroded bronze artifact among the remains of an ancient shipwreck. At first, it appeared to be just another piece of debris from the wreck. However, when examined closely, it revealed a complex system of gears, inscriptions, and dials. a level of craftsmanship far ahead of its time. The Antikethyra mechanism, often referred to as the world's first analog computer, is believed to date back to around 100 to 200 BCE. It is an astronomical calculator that could predict celestial movements, eclipses, and even track the Olympic Games. But how did the ancient Greeks create such an advanced device over 1,500 years before similar mechanical systems appeared in Europe? This deep dive will explore what the Antikethyra mechanism is, how it was built, what it was used for, and the enduring mysteries surrounding it. Could there have been a lost lineage of ancient technological knowledge? Let's uncover the secrets of this remarkable artifact, the discovery of the Antikethyra mechanism. In 1900, Greek sponge divers searching for sea sponges accidentally stumbled upon an ancient shipwreck near the island of Antikethyra. Over the next year, archaeologists recovered statues, pottery, jewelry, and various artifacts from the wreck. But the most intriguing find remained unnoticed: the moment of recognition. In 1901, archaeologist Valerio Stais examined what seemed to be a corroded chunk of bronze. He noticed gears, inscriptions, and mechanical components embedded within the metal. Over time, it became clear that this was not just a decorative piece, but a highly sophisticated mechanism. However, for much of the 20th century, the significance of the device was overlooked due to its extreme corrosion and lack of similar artifacts from the ancient world. What is the Antikethyra mechanism? The Antikethyra mechanism is a bronze hand-powered device with over 30 interlocking gears, dials, and inscriptions that appear to model astronomical phenomena with extreme accuracy. Key features of the mechanism: astronomical calendar, tracks the positions of the sun, moon, and possibly the planets. Eclipse prediction, calculates solar and lunar eclipses with high precision. Lunar phase tracker, displays the phases of the moon based on complex mathematical cycles. Zodiac and star calendar, aligns with the zodiac cycle and ancient Greek calendars. Olympic Games counter, one of the dials appears to track the 4-year cycle of the Olympic Games. The sheer complexity of this device challenges our understanding of ancient technology. Before its discovery, historians believed that gears and precision engineering of this type only emerged in the 14th century CE, over 1,500 years later. The technological marvel of the Antikethyra mechanism: unprecedented mechanical engineering. The device uses a system of differential gears, a technology thought to have been invented in the Renaissance. It demonstrates an understanding of advanced mathematical cycles, such as the Metonic cycle, 19-year lunar cycle, and the Saros cycle, 18-year eclipse cycle. The mechanism likely required highly skilled craftsmanship, with bronze gears cut with astonishing precision. Who built it? The origins of the Antikethyra mechanism remain uncertain. Possible contributors include Hipparchus circa 190 to 120 BCE, a Greek astronomer known for developing the concept of celestial coordinate systems; Archimedes circa 287 to 212 BCE. While not directly linked, some believe his mathematical knowledge may have influenced its design. A lost tradition of Greek engineering? Could this device be evidence of an advanced Greek workshop or school of technology lost to history? The mysteries that remain unsolved. Was the Antikethyra mechanism unique? No other devices like it have ever been found from antiquity. Was it a one-of-a-kind invention, or did similar mechanisms exist but were lost over time? Could there be more discoveries waiting beneath the sea? What was it used for? The mechanism clearly served as an astronomical calculator, but was it purely for academic use, religious purposes, or even navigation? Some suggest it was a tool for seafarers, allowing Greek sailors to track celestial movements and navigate the Mediterranean. Others believe it was used for educational and ceremonial purposes in elite circles. How did the knowledge disappear? If the Greeks could build this, why did such technology vanish for over a millennium? Did this knowledge survive in secret manuscripts, only to be lost due to war, conquest, or natural disasters? Modern research and reconstructions. Since the late 20th century, scientific efforts have intensified to understand and reconstruct the Antikethyra mechanism. Breakthrough discoveries. In 2005, advanced X-ray imaging revealed new inscriptions and hidden gears. In 2021, researchers at University College London created the most complete digital model of the mechanism. 3D printed replicas now allow scientists to experiment with its functions and confirm its accuracy. What have we learned? The inscriptions suggest Greek origins, but with possible Babylonian and Egyptian influences. The device was likely built by a skilled workshop, but whether it was a common practice or a unique experiment remains unknown. Could the Antikethyra mechanism change our understanding of history? The existence of such advanced engineering in 200 BCE raises profound questions about ancient civilizations. How much ancient technological knowledge was lost over time? Could there be more ancient devices hidden beneath the oceans or buried in ruins? Was Greek science even more advanced than we previously thought? The Antikethyra mechanism challenges the linear view of technological progress, suggesting that ancient civilizations may have been far more sophisticated than previously believed. A glimpse into a lost world. The Antikethyra mechanism is more than just an artifact. It is a time capsule of ancient genius, revealing a forgotten chapter in human innovation. Was it a one-of-a-kind invention, or does it hint at a lost legacy of ancient technology? As modern science continues to decode its secrets, this device bridges the gap between ancient wisdom and modern discovery, reminding us that history still holds many hidden wonders waiting to be uncovered. The cosmic microwave background (CMB) is the faint radiation left over from the Big Bang, serving as a blueprint of the early universe. It is a nearly uniform glow that fills all of space, but within it, scientists have discovered an unexplained anomaly, a massive cold spot, a region significantly cooler than expected. This mysterious cold spot, located in the constellation Eridanus, is approximately 1.8 billion light-years across and is colder than the surrounding regions by about 70 microkelvin. The standard model of cosmology struggles to explain why this region exists. Some hypotheses suggest it could be a supervoid, while others entertain more radical ideas, such as the imprint of a parallel universe colliding with ours. Could the cold spot be a natural feature of the universe, a glitch in our understanding of physics, or even evidence of something more profound? In this deep dive, we will explore what the cold spot is, how it was discovered, possible explanations, and what it cold mean for our understanding of the cosmos. 1. What is the cosmic microwave background, CMB, the afterglow of the Big Bang? The cosmic microwave background is the oldest light in the universe, a relic from the time when the universe was just 380,000 years old. Before this period, the universe was so hot and dense that atoms couldn't form, and light couldn't travel freely. As the universe cooled, it became transparent, allowing light to escape. This light is the cosmic microwave background we detect today. The CMB is often described as the fingerprint of the early universe, because it provides insights into the universe's infancy. It is incredibly uniform, but tiny fluctuations in temperature reveal variations in matter density, gravitational influence, and cosmic structure formation. However, within this seemingly random pattern, scientists have identified one particularly large and unexpected cold region, the cold spot. 2. Discovery of the cold spot. The cold spot was first detected in 2004 by the Wilkinson Microwave Anisotropy Probe, UWMAP, a NASA mission designed to map temperature variations in the CMB. Later in 2013, the European Space Agency's Planck satellite confirmed the anomaly with even greater precision. Why is the cold spot strange? Size: it spans roughly 1.8 billion light-years, making it one of the largest known anomalies in the universe. Temperature: it is about 70 microkelvin colder than the surrounding CMB. Location: it is found in the Eridanus constellation, a region not associated with known cosmic structures that could explain such a massive anomaly. Statistical rarity: the probability of such a large cold region forming naturally in the CMB is less than 1%. If the cold spot cannot be explained through standard cosmic evolution, it may point to new physics, or even exotic theories of the multiverse. 3. Possible explanations for the cold spot. Scientists have proposed several theories to explain the cold spot, ranging from conventional physics to speculative and revolutionary ideas. 1. The supervoid hypothesis, standard explanation. One of the most widely accepted explanations is that the cold spot is caused by a supervoid, a vast region of space with fewer galaxies and less dark matter than average. In 2015, a team of astronomers found evidence of a 900 million light-year-wide supervoid in the same region as the cold spot. The idea is that this void affects light traveling through it due to the integrated Sachs-Wolf effect, where photons lose energy when exiting a gravitational well, making the CMB appear colder. However, simulations suggest that the observed supervoid is not large enough to fully explain the cold spot's temperature dip. While this remains the leading theory, it does not entirely match observations, leaving the door open for alternative explanations. 2. Quantum fluctuation in the early universe. Another possibility is that the cold spot is simply the result of a rare quantum fluctuation from the early universe. During the inflationary period, microscopic quantum fluctuations were stretched to macroscopic scales, forming the structures we see today. Some cosmologists suggest that the cold spot could be an extreme but naturally occurring density variation. However, statistical models suggest that such a large anomaly is unlikely to form purely by chance. 3. The multiverse hypothesis. A collision with another universe? One of the most exciting and speculative explanations is that the cold spot is evidence of a collision between our universe and another parallel universe. Some theories of cosmic inflation suggest that our universe is just one of many bubble universes forming in a vast multiverse. If two of these bubbles collided in the early universe, the interaction could leave an imprint on the CMB, appearing as an unusual cold region. Some physicists argue that the cold spot matches what would be expected from such an interaction. If true, this would be the first observational evidence of a multiverse, fundamentally reshaping our understanding of reality. Exotic physics and unknown forces. Other speculative explanations include primordial cosmic defects, such as domain walls or textures, which could arise from unknown physics during the early universe. Anomalous dark matter distributions that might create unexpected gravitational effects. Undiscovered modifications to general relativity, suggesting gravity behaves differently at cosmic scales. These ideas remain purely hypothetical, but could lead to new physics beyond the standard model. The significance of the cold spot. Why does this anomaly matter? The cold spot challenges our understanding of cosmology, inflation, and fundamental physics. It may reveal gaps in the standard cosmological model. If linked to the multiverse, it could provide the first physical evidence of other universes. It could force scientists to revise theories of cosmic inflation and structure formation. Ongoing research and future investigations. To solve the mystery of the cold spot, astronomers are conducting deeper studies. Next-generation CMB observations. Projects like the Simons Observatory and future space telescopes will refine CMB maps to search for similar anomalies. Deep sky galaxy surveys. Mapping cosmic structures in greater detail to confirm or refute the supervoid hypothesis. Theoretical cosmology advancements. Investigating how inflation, quantum fluctuations, or exotic physics could explain such a large anomaly. If further anomalies like the cold spot are found, it could redefine our understanding of the universe's large-scale structure. A window into the unknown? The cold spot in the cosmic microwave background remains one of the most puzzling mysteries in modern cosmology. Whether it is a giant cosmic void, an extreme fluctuation, or even evidence of another universe, it challenges our understanding of the cosmos in profound ways. As scientists continue to refine our knowledge of the early universe, the cold spot may hold the key to discovering new physics, or even proving the existence of a multiverse. In October 2017, astronomers detected a mysterious object hurtling through our solar system. It was unlike anything ever seen before, an elongated, tumbling, interstellar object moving at an extraordinary speed. Named Umaumau, a Hawaiian term meaning scout or messenger from afar, this strange visitor has puzzled scientists ever since. Unlike comets or asteroids, Umaumau exhibited anomalous behavior that defies easy explanation. It had no visible comet tail, yet it mysteriously accelerated as it left the solar system. Its shape was unlike any known natural object, leading some scientists, including Harvard astrophysicist Avi Loeb, to propose the possibility that it might be an artificial probe from an advanced civilization. Is Umaumau a rare interstellar object, an unknown natural phenomenon, or evidence of extraterrestrial intelligence? In this deep dive, we will explore what we know about Umaumau, its unusual characteristics, the theories surrounding it, and what it could mean for the search for alien life. The discovery of Umaumau. Umaumau was first spotted on October 19, 2017, by the Pan-STARRS 1 telescope in Hawaii, which was scanning the sky for near-Earth asteroids. At first, astronomers assumed it was a typical comet or asteroid, but as more data came in, it became clear that this object was something entirely different. Key facts about Umaumau origin: it came from outside our solar system, making it the first confirmed interstellar object ever observed passing through. Speed: it was traveling at 196,000 miles per hour, 315,000 kilometers per hour, too fast to be bound by the sun's gravity, meaning it was just passing through. Unusual shape: Umaumau appeared to be long and cigar-shaped, measuring about 800 meters long, but only 80 meters wide. An aspect ratio unlike any known asteroid or comet. Unexpected acceleration: as it exited the solar system, it sped up, even though it showed no visible outgassing, unlike a typical comet. Tumbling motion: instead of spinning like most space objects, Umaumau tumbled chaotically, suggesting it had been traveling through space for millions of years. These anomalous features set off a scientific debate. What was Umaumau, and why was it behaving so strangely? What makes Umaumau so mysterious? While astronomers generally classify objects as asteroids, rocky, or comets, icy with a tail, Umaumau did not fit either category neatly. Here's why. No comet tail, yet it accelerated normally. Comets accelerate due to the outgassing of sublimating ice, which creates a visible tail as they heat up near the sun. Umaumau had no visible gas emissions, dust, or tail, yet it accelerated in a way consistent with comet-like behavior. This means it was being pushed by an unknown force, which defies the standard model of celestial mechanics. Unusual shape and structure. Most natural space objects are either round, due to gravity, or irregularly shaped, like asteroids. Umaumau's extreme cigar or pancake-like shape has never been observed in any natural space object. This shape would be ideal for a light sail, a potential technology used by advanced civilizations for interstellar travel. Anomalous reflectivity. Umaumau's surface reflected light unusually well, suggesting it was made of a highly metallic or artificial material. Some scientists argue that its reflectivity is consistent with interstellar dust accumulation, but this is still debated. Its unusual rotation. Unlike most space rocks that spin in predictable ways, Umaumau tumbled unpredictably. This suggests it had an unknown origin and had been tumbling for millions of years before entering our solar system. These characteristics challenge our understanding of interstellar objects, leading to multiple competing theories. Theories about Umaumau's origin. Since its discovery, scientists have proposed several explanations for Umaumau's strange behavior. A natural interstellar object, the mainstream explanation. Most astronomers believe Umaumau is a rare, elongated fragment of a shattered planetary body. Some suggest it might be a frozen hydrogen iceberg, which could explain its acceleration without visible outgassing. However, no hydrogen icebergs have ever been observed before, making this explanation speculative. A giant flake of interstellar dust. A 2020 study suggested that Umaumau could be a thin, ultralight fragment of interstellar material pushed by solar radiation pressure. While plausible, this does not fully explain its anomalous acceleration and unusual shape. Alien technology, a light sail or probe. Harvard astrophysicist Avi Loeb proposed that Umaumau might be an artificial structure, possibly a discarded light sail from an alien civilization. A light sail is a thin, reflective object that uses radiation pressure from a star to accelerate. If true, this would mean Umaumau was either a functional probe or debris from an alien spacecraft. While most scientists remain skeptical of the alien hypothesis, Loeb argues that we should not dismiss it outright without further investigation. 4. What could Umaumau mean for science? Whether it was a natural object or something more, Umaumau has profound implications. It confirms that interstellar objects do pass through our solar system. It challenges our understanding of planetary formation and cosmic debris. It raises the possibility that we are not alone, and that advanced civilizations could send probes to explore other star systems. The search for more interstellar visitors. Since Umaumau's detection, astronomers have been searching for similar objects. In 2019, a second interstellar object, 2I/Borisov, was discovered, but it behaved more like a typical comet. Future telescopes, like the Vera C. Rubin Observatory, will scan the sky for more interstellar objects, potentially uncovering others with similarly strange characteristics. In addition, the Galileo project, led by Avi Loeb, aims to develop new methods to detect and study anomalous interstellar objects, including the possibility of investigating them with spacecraft. Conclusion: a mystery that remains unsolved. Umaumau remains one of the most perplexing mysteries in modern astronomy. It could be a never-before-seen natural object, an unknown phenomenon, or even evidence of advanced extraterrestrial technology. Until we find more interstellar objects like it, or develop missions capable of chasing them, its true nature will remain unknown. Could Umaumau be a scout from an alien civilization, or was it just a cosmic anomaly? Whatever the answer, it has changed how we look at the universe and opened new doors in the search for interstellar phenomena and potential extraterrestrial life. For decades, a persistent and unexplained low-frequency noise has been reported by people around the world. This phenomenon, known as the Taos Hum, is named after the small town of Taos, New Mexico, where residents have described a continuous, low droning sound that seemingly has no identifiable source. What makes the hum particularly puzzling is that only some people can hear it, while others in the same location perceive absolute silence. Despite extensive scientific investigations, the cause of the Taos Hum remains unknown. Some theories suggest it might be the result of industrial activity, geophysical processes, or even an auditory illusion, while others speculate more exotic explanations, such as military experiments or extraterrestrial activity. Could the Taos Hum be a natural phenomenon, a product of human-made technology, or something even stranger? In this deep dive, we will explore what the Taos Hum is, the evidence for its existence, the leading scientific theories, and the unanswered questions that still surround it. 1. What is the Taos Hum? The Taos Hum is described as a low, persistent droning sound that is often compared to a distant idling diesel engine, a low-frequency vibration, a deep, unending hum that people cannot escape. Key characteristics of the Taos Hum: selective hearing. Only about 2 to 10% of the population in affected areas can hear it. Low frequency, typically reported in the range of 30 to 80 Hz, just on the edge of human hearing. Global reports. Although named after Taos, similar hums have been reported worldwide, including in Bristol, UK, Largs, Scotland, Windsor, Canada, and Kokomo, Indiana, USA. No clear source. The sound does not appear to originate from a specific direction, making it difficult to locate. Varied symptoms. Some individuals claim the hum causes headaches, nausea, sleep disturbances, and even anxiety. 2. Who can hear the hum? The hearers versus the non-hearers. One of the most perplexing aspects of the Taos Hum is that only a small percentage of people in an affected area can detect it. These individuals are known as hearers, while those who cannot hear it are called non-hearers. Hearers describe the hum as invasive, disruptive, and sometimes maddening. Non-hearers remain unaware of any unusual sound, even when standing next to hearers in the same location. Hearing tests show that hearers generally have normal auditory function, ruling out typical hearing disorders as a cause. Some hearers report that the sound gets stronger at night or in rural areas, away from city noise. This discrepancy raises serious scientific questions. If the sound is real, why do only some people detect it? Could it be a result of individual biological differences, or is it a psychological phenomenon? 3. Scientific investigations and theories. Since the Taos Hum became widely known in the 1990s, numerous studies have been conducted to determine its cause. However, no definitive explanation has been found. Below are some of the leading scientific hypotheses. 1. Industrial or mechanical sources, man-made theory. Some researchers believe the hum could be the result of low-frequency noise from industrial sources such as high-pressure gas pipelines vibrating underground, electrical transformers and power grids emitting low-frequency sounds, cell phone towers or radio transmissions. However, investigations in Taos ruled out known industrial sources, as turning off power grids or industrial activity did not make the hum disappear. 2. Geophysical activity, Earth-based theory. Some scientists speculate the hum could be related to natural geological or atmospheric phenomena, such as seismic activity. Underground tectonic movements could create infrasound waves that are only heard by sensitive individuals. Ocean waves and resonance. The Earth itself produces constant low-frequency sounds, known as the microseismic hum. Geomagnetic interactions. Variations in the Earth's magnetic field could affect people's perception of sound. While plausible, these explanations do not account for why only a small subset of people can detect the hum. 3. Auditory and neurological theories, psychological or physiological theory. Another hypothesis is that the hum is a neurological or auditory phenomenon, rather than an actual external sound. Possible explanations include tinnitus, a medical condition causing people to hear internal ringing or buzzing sounds. Auditory sensitivity. Some individuals may have an enhanced ability to hear low frequencies that others cannot detect. Spontaneous autoacoustic emissions. The human ear sometimes produces its own faint sounds, which might be perceived as an external hum. However, most hearers insist that the hum is external and different from traditional tinnitus. 4th, government and military experiments, conspiracy theories. Some alternative explanations suggest that the Taos Hum could be linked to classified government projects or military technology. Low-frequency military communications. The military uses extremely low-frequency, ELF, waves to communicate with submarines. Could these signals interfere with human hearing? HARP and electromagnetic weapons. Some believe advanced technology, like the High-Frequency Active Auroral Research Program, HARP, could be unintentionally causing the hum. Mind control or psychological experiments. Some conspiracists claim the hum is a test of mass psychological manipulation. There is no solid evidence supporting these claims, but the secrecy surrounding military projects fuels speculation. 4. Why does the hum matter? The Taos Hum is more than just a mysterious noise. It raises fundamental questions about human perception, physics, and the unknown forces at work in our environment. If it is real, why can only some people hear it? If it is psychological, why do hearers describe it so consistently across the world? If it is caused by external sources, why has no device been able to conclusively detect it? Could it be an undiscovered natural phenomenon? Regardless of the cause, the Taos Hum has had real-world effects, with some people moving away from affected areas due to the distress it causes. 5. Is there a solution? Can the hum be stopped? Despite decades of research, there is no universal solution to stopping the hum. However, some hearers have reported temporary relief through noise masking techniques, such as white noise machines, soundproofing homes to reduce external vibrations, meditation and relaxation techniques, which seem to help those affected by stress-related hum perception. Moving to different locations, some hearers report that the hum disappears in certain areas. Until the source of the hum is identified, there is no clear way to eliminate it. Conclusion: a sound that defies explanation. The Taos Hum remains one of the most baffling and persistent auditory mysteries in modern science. Whether it is a man-made phenomenon, a natural geophysical effect, or a neurological condition, its cause is still unknown. Could future scientific advancements finally explain it, or will it remain one of the great unresolved enigmas of human perception? Science has unlocked many of nature's deepest secrets, from the structure of the atom to the vastness of the cosmos. Yet for all our progress, we are still surrounded by profound mysteries that defy explanation. Some lie at the frontiers of physics, challenging our understanding of space, time, and reality itself. Others dwell within the mind, questioning the very nature of consciousness and perception. There are even mysteries hidden in the everyday world, strange signals from deep space, unexplained biological phenomena, and forces we can measure but not yet comprehend. What are the limits of our knowledge? Are these mysteries simply unsolved puzzles waiting for better tools and theories? Or do they hint at something deeper, something beyond the scope of human understanding? As we explore the greatest unanswered questions of science, we find that each mystery is not just a problem to be solved, but a doorway to new realms of discovery. The unfinished story of the universe. The universe, as vast as it is, remains largely unknown. From the moment of the Big Bang to the distant reaches of space, there are forces and phenomena that defy explanation. We know the universe is expanding, but why is it accelerating? What is the nature of the dark energy driving this expansion? Despite making up the majority of the cosmos, dark matter and dark energy remain elusive, detected only by their gravitational influence. At the smallest scales, the fabric of reality itself remains uncertain. Quantum mechanics has shown that particles can exist in multiple states at once, and that observation itself can change an outcome. Do these strange behaviors point to hidden dimensions or an underlying structure of reality we have yet to comprehend? Some of the most intriguing questions lie in the possibility of multiple universes. Could our cosmos be just one of many, each with its own laws of physics? If so, what would that mean for our understanding of existence? The enigma of life. Life itself is one of the greatest mysteries of all. We understand how life evolves, how cells function, and how DNA encodes information. Yet we still do not know how life began. Did it arise from a primordial chemical reaction on Earth, or was it seeded from space? Could life be an inevitable outcome of the laws of chemistry and physics, or is it an exceedingly rare accident? Even more puzzling is the possibility of life beyond Earth. With billions of habitable planets in our galaxy alone, the conditions for life should exist elsewhere. Yet we have found no definitive proof of extraterrestrial civilizations. Are we truly alone, or are we simply searching in the wrong way? The nature of intelligence, consciousness, and the factors that shape the development of advanced life remain some of the most profound unknowns in science. The mystery of consciousness. Of all the enigmas science faces, consciousness may be the most perplexing. How does the human brain generate self-awareness, emotions, and thoughts? Neuroscientists have mapped the brain's activity in exquisite detail, but there is no clear explanation for why or how subjective experience arises from biological processes. Some theories suggest that consciousness is an emergent property of complex information processing. Others propose that it is a fundamental aspect of reality, much like space and time. Could consciousness extend beyond the brain? Do animals, plants, or even entire ecosystems possess forms of awareness we do not yet recognize? The mystery of the mind is tied to some of the biggest philosophical questions ever asked. If artificial intelligence reaches a certain level of complexity, could it become conscious? And if we cannot define what makes us aware, how will we ever answer whether machines or other life forms possess consciousness of their own? The unseen forces shaping reality. There are forces at work in the universe that we cannot directly perceive, but whose effects we can measure. The force of gravity, described so elegantly by Einstein's general relativity, still raises unanswered questions about its true nature. Could it be connected to quantum mechanics, forming a deeper theory of everything? Similarly, electromagnetism, the weak force, and the strong nuclear force govern much of the universe at the smallest scales. Yet physicists still seek to unify them into a single framework. Could there be a fifth force of nature waiting to be discovered? Beyond these forces, there are patterns and unexplained signals that defy classification. Mysterious fast radio bursts from deep space, anomalies in the cosmic microwave background, and unexplained gravitational influences all point to the possibility that we are only scratching the surface of the universe's hidden structure. The future of unsolved science. The mysteries of science are not signs of failure, but of opportunity. Every great breakthrough was once an unanswered question. The strange and the unexplained push us forward, forcing us to develop new technologies, refine our theories, and rethink our understanding of reality. In the coming decades, new telescopes, particle accelerators, and space missions will allow us to explore deeper into the cosmos and the quantum world than ever before. Advancements in neuroscience and artificial intelligence may unlock the secrets of the brain and consciousness. The search for extraterrestrial life, whether microbial on distant moons or intelligent civilizations beyond our own, continues to expand. But perhaps the most important realization is that science may never fully answer every question. Some mysteries may remain forever beyond human comprehension, constrained by the limits of our minds and the nature of the universe itself. Embracing the unknown. The greatest mysteries of science remind us that we live in a universe far more complex and fascinating than we can currently comprehend. Rather than seeing the unknown as a barrier, we should view it as an invitation to explore, to question, and to push the boundaries of what is possible. What lies beyond the edges of our knowledge? Are we on the verge of revolutionary discoveries that will reshape our understanding of reality? Only time will tell, but one thing is certain.